So here we're in Calculus 1. We're looking at problem number 4 from homework set number 6. And here are the different slopes at the different time values. So again, how we get those values, let's go ahead and check. So for this problem, we've got an airplane that's flying at an altitude of 5,000 feet. We put an extra 0 there. That'll make a difference in the problem here. So it's at an altitude of 5,000 feet, which is approximately a mile, just a little bit underneath. And it's flying at 200 miles per hour directly overhead. And so it passes, and there's just some little person down here with a telescope, and he's spotting the plane. So at first the telescope's completely vertical, and then it's going to change its elevation, and we're looking for the slope. So if the slope is up here, if the telescope's up here, okay, at a height of 5 feet, this right here, if it's 5,000 feet over an individual, the telescope mounted, it's really negligible, that's this extra 5 feet, but let's just say that the total length between the top of the telescope and the airplane is 5,000. So now what we need to do is we need to figure out this thing in terms of feet per second. And the reason I need it in feet per second is, one, I need it in feet so that I can compare it with this value right here. And then second, I would like it in seconds because the problem asks for the time in seconds. So 200 miles in 1 hour, I'm going to have to multiply to get that from miles into feet. I need another conversion there, so 5,280. And then I'll need to multiply that by 1 hour versus 3,600 seconds. Okay, so let's go ahead and do this conversion. So we've got 200 times 5,280, and then we have to divide that by 3,600, and that gives me approximately 293.3 repeating. Well, that's not approximate, that's exact. But so this plane is flying at 293.3 repeating feet in 1 second. So at t equals 0, the telescope is directly up. So the slope of the telescope is undefined. At t is equal to 10 seconds, well, if every second it goes 293.3 feet, if we multiply that by 10, in 10 seconds, the change in the y value, its height value, hasn't changed, right? Okay. The change in the plane hasn't changed. However, the telescope is now pointing like this. So the y value, the delta y, the change in the y, this guy right here is still 5,000. And the delta x, this length right here, okay, so let's put 5,000 here. And the change in its horizontal distance, we've calculated at 2,933.3 repeating. And so the slope, let me just grab that guy out, is 1.70454 approximately. Okay, so that's the slope. Nothing to do with the angle, just the slope. And then when t is equal to 20, this guy down here becomes twice as large, right? Because it's going to travel that distance, it's going to travel it again. So it looks like that. So now change of x is this whole length here, so twice this guy. The change in the y value is still the same. So if we just take this thing and divide it by 2, we get a change in y over a change of x of 0.85227 approximately. What is the slope? Oh, hang on. What is the slope at t seconds? When at t seconds, it's going to be 5,000 times 293.3 times t, right? Because for every second we travel this many feet, that's how much our x changes. Okay, so this is our in t seconds.